Where that's coming from.
All right, what did you, which is it,
The
Brendan?
589.
Where did that come from?
Hmm?
Are you asking where did the
That's
589?
where I was
That's the wrong
asking.
number.
So, it's not 589?
I think it's
No.
357 because
That's what I
Okay.
that's why I was just confused on like where the 589 was coming from.
All right, sorry, I might have wrote it wrong. Yeah, because the difference between those two numbers is 12.
I know, Morgan. I was looking back too, and I was like,
All right.
It's
what?
10.
All right, you probably had
Just
it
follow
right
it's
on your
10,
paper.
not 12, 10.
Like, I was
Pardon?
like, right
10
as
between
I
those
was
two
seeing
numbers
it.
is 10, not
When I
12.
look back
Really?
up, I'm like, it's 12.
Yeah,
But where
because
did
if
that
you
number
just
come from?
subtract,
It's not
it's
on
10.
the calculator anymore.
So it was 357?
Yeah.
All right, so then this is 10.
Yep.
All right, 1.0 times 10
Well,
to...
I had to round up.
Pardon?
I had to round up.
Up to 11?
Yeah.
Okay. Well, the difference between these two, oh, so what do you mean, what did you round up? The difference between these two numbers is exactly 10.
Yeah.
All right,
I think because it was decimals. because
okay,
of the
you were carrying some
1.03,
decimals,
I
okay,
didn't
okay.
change that. I just kept-
All right, look back on this example, when we multiplied 1.03 times 347, I had the wrong number right there. So it's 357, which when I subtract 347, it's 10. If you were carrying extra decimals and you rounded it up, you might have gotten 11, but that's good. All right, any other discussion there? All right, I'll leave that part there. All right, another type of problem that I want you to be aware of is thunderstorm problems. So we'll talk about that. In order to do a thunderstorm problem, did you start it again?
Yeah.
Okay.
It's been started for a
You
while.
have to, the main formula is just our third grade one, distance equals rate times time. It's not a big fancy one like Doppler. So write down the formula. Distance is rate or velocity times time. And we're going to discuss this aspect of a thunderstorm. Let's say that there's a lightning that occurs and we hear the thunder, we see the lightning, and we were able to time how long it takes before the thunder hits, and it's 1 second. So 1 second is the time between lightning and thunder. And of course, my question is, how far away is the storm? How far away is the lightning? Is there an E in lightning? Yes.
Is it true that for each second between the thunder and the lightning is a mile?
We'll figure that out right now. Our answer will allow us to figure that out. Okay. All right, when we get done, we'll be able to calculate in the way that Molly said the distance between you and the lightning strike. Again, lightning is light, so it hits your eyes very quickly. The thunder is sound, it comes slowly, but they both start at the same time. It's just that one gets to you a lot later than the other. And if you count the difference between the two, you should be able to calculate how far away the lightning is. So, let us actually use this formula. Distance equals rate times time. We need to know the air temperature, of course, to figure this out. Let's say it's a cool 15 degrees Celsius. So, 15 degrees. So, in order to get the velocity of the sound, which is what R is here for rate, I need you to throw it into the formula that we had, I just erased up there. Is that, what is it again, Alex? I always forget that number.
331.5.
331.5, let me get it down again. I know the .606. I always say 335.1 and get it all wrong. All right, use our velocity of sound and air formula to find out the velocity of the sound in when it's 15 degrees Celsius. Plug that in here and share your number so we can compare it to others.
I got 341.
341, anyone else?
That's what I got.
341, okay. So that is the velocity, I called it rate in here, same thing. And how long was the time? 1 second. So that's not a difficult calculation. So we get the distance to be 341 meters. Are we in meters? Are we in meters? What are we? Yes, because we use this formula, we're in meters. It turns out that 341 meters is about a fifth of a mile, pretty close.
So it's 5 seconds.
So a fifth of a mile, so if it's 1 second is fifth of a mile, that means if you count to 5, then you have the storm is a mile away. So once you see the lightning, 1, 2, 3, 4, 5. If you can count to 5, it's a mile away. If you can count to 10, it's 2 miles away. So
We should wait.
yeah, we could practice it, right?
7.
All right.
7. 10.
All right. I guess there is another loose end that we have to tie up before I go on to the next topic. That's the third time I've said that. But when let me give you the definition for wave, and I'm going to leave a blank, and you fill it in. A wave is a disturbance that propagates through a blank. What is
Medium.
a medium? Remember, it's the first thing we did.
No.
So the medium, like when I yell at you, the medium between my mouth and your ears is air molecules. Can I yell at you? Can I yell at you in
Yes.
space?
Yes.
No, I'm not asking
Oh.
can I yell at
Oh, I want
you.
you
My
to yell
voice
at
hurt the rest of that day,
Can
so
you yell at us right now?
no. Weren't you here? I did it once.
Just so you're paying attention.
My voice isn't strong enough to yell anymore. It's pretty bad. Can I yell at you in outer space?
No.
No, there's no medium there. So let us observe air, and we're going to take a bell jar, and we're going to put a ringing bell in it, a bell-shaped jar of glass. It's very strong. And we're going to put a bell in it, and we're going to turn the irritating bell on, and we're going to pump out all the air. So we should hear the sound diminish and disappear. Should, right? All right.
Does it not work?
Abby, could you help me move this device over to the front?
Alex. What does that mean?
You take that, but it's connected, so hold on a second, and I don't want to lose that little screw.
Miss Powell,
Yeah.
there's a little yellow thing on the screen. What does that mean?
There's a what?
Little yellow thing, like really, really little, and it's like flashing.
That doesn't sound good, does it?
I don't know what it is.
All right. Huh, I thought that I charged it. I usually recharge it. If it run out, we run out, and I'll just have to explain the rest to her at home, so.
Okay.
All right, can you show her? Can you move the camera so she can see?
You get hands-on footage.
How do you even take this thing off? Abigail.
You think we can put this up on the table, that pump?
Yep.
All right.
Oh, I was gonna take off. That's cool.
All right, can she see that?
Yeah.
Yep.
Okay. All right, here we go, turning on the, you mind staying up and cranking?
Nope.
All right. Watch everyone file out like it's a fire alarm. All right, this is not because it's pumped out, it's because I covered it. But now we're gonna pump out the air, okay?
Can you hold it?
That's why we got it on the floor. If you want to put it down. The smell you smell is the oil in this. If you get this, you will. Takes a while. If you get tired, you can pass it on. But you get sweaty.
I hope I don't get sweaty from this.
That'd be disappointing.
I think it's starting to get low.
Yeah.
And if you come up and try to pull this off, it won't come. see. There's a big section there. It stinks. Can you smell it, Jonathan?
Not yet.
It smells like a car.
It smells like natural gas, but it's